Hey there, junior investigators. I'm your resident astronomer, and today we're cracking open a massive astronomical cold case in this explainer. We're going to investigate a colossal mystery that's literally pulling on our very own galaxy. We're tracking the clues and trying to make sense of one of the universe's most captivating, hidden secrets. Okay, let's just dive right into this. I want you to imagine an enormous gravitational force dragging the Milky Way through the cosmos. And we're not just talking about our galaxy. We're talking about millions of neighboring galaxies, all being inexorably pulled toward a single, hidden point in deep space. I mean, it sounds like pure science fiction, right? But here's the catch. When we actually try to look for the culprit, the massive object responsible for this insane cosmic tug-of-war, something huge blocks our view. It's essentially the ultimate locked-room mystery, but played out on a galactic scale. Section 1. The Great Cosmic Mystery. The gravitational anomaly dominating our universe. So, to kick off our investigation, we need to define exactly what phenomenon we're tracking down. The crucial point here is that this Great Attractor, well, it has so much concentrated mass that its gravity literally dominates our local cosmic neighborhood. It's not just a cool, catchy name. It's a very real region of space where matter is packed so incredibly densely that its gravitational field dictates the traffic of absolutely everything around us. Think of the universe as a giant ocean. The Great Attractor is the massive current pulling our ship along. Section 2, our dusty cosmic blind spot. Why the culprit remains hidden. Now, hitting a roadblock is just part of any good investigation, right? And our main obstacle here is, ironically, the Milky Way itself. Think of the plane of our galaxy as this incredibly thick, foggy window sitting right smack between us and the Great Attractor. Because we're sitting inside the Milky Way, looking out toward this mysterious gravitational pull, means we have to look directly through the absolute densest part of our own galactic home. And there are two big reasons our view gets completely blocked. First off, the incredibly dense center of the Milky Way just outshines everything. We're talking millions of bright foreground stars essentially blinding our cameras to the faint light trying to reach us from the background. Second, there are these super thick clouds of cosmic dust, physically blocking the light from deep space. So you have this 1-2 punch of blinding light and thick dust, leaving the zone directly behind our galaxy center an almost total mystery to astronomers. Section 3. Seeing the invisible universe. Using forensic tools to peer through the dust. To actually crack this case, we need some serious forensic tools. We need supervision goggles that let us peer right through that dusty window. Now, what's really fascinating here is the contrast. While traditional optical telescopes, like Hubble, are just blinded by all that cosmic dust, we can use infrared and radio observations to trick our way into seeing the hidden universe behind it. Because infrared and radio waves are much longer than visible light, they can slip right through those thick dust clouds completely undisturbed. It's exactly like a detective using thermal goggles at a crime scene to spot clues that the naked eye just completely misses. Section 4. Meeting the Norma Cluster. Identifying our prime suspect. Armed with these awesome multi-wavelength tools, we finally spot our prime suspect hiding out on the border of the Triangulum Australe, the Southern Triangle, and Norma, the Carpenter Square, constellations. We're looking at the Norma Cluster, which is also known in astronomical catalogs as Abell 3627. This thing is a massive collection of galaxies with just unbelievable gravitational influence. When our infrared and radio telescopes finally pierced the Milky Way's dust, this colossal structure emerged from the shadows. And this perfectly illustrates the sheer, mind-boggling scale of our investigation. The Norma Cluster is the closest massive galaxy cluster to the Milky Way, but it still lies a staggering 220 million light-years away. But get this, even from that impossible distance, the enormous mass concentrated there is still pulling on our galaxy, cementing it as the anchor of the Great Attractor. Section 5. The secret of ESO 137-002. A galaxy torn apart by gravity. Let's zoom in on a specific victim of this cluster's massive mass to really see how the Great Attractor influences the movement of surrounding galaxies. The largest galaxy we can spot in this field of view is an edge-on spiral galaxy known as ESO 137-002. Seriously, if you want to know just how powerful the Norma Cluster's gravity is, you just have to look at what it's doing to the galaxies unlucky enough to be caught in its web. When we look at exposures in blue and infrared light taken by Hubble's advanced camera for surveys, we can clearly see the physical shape of this galaxy. You can spot the large dust region spreading across its bulge. In this optical view, honestly, it actually looks quite peaceful, right? Just hovering there in the dark like a glowing, dusty disk. But remember our hidden evidence. The optical view totally misses the most violent part of the gravitational interaction happening here. Hubble is an incredible, absolute powerhouse of a tool, but even it has limits when looking at certain types of high-energy cosmic events. When we look at this exact same galaxy with different instruments, a terrifying hidden clue emerges. X-ray sensors reveal this massive tail of glowing X-rays being violently ripped out of ESO 137.002. This completely proves the intense gravitational forces tearing it apart in this deep space neighborhood. The gravity of the Great Attractor is so intense that as this spiral galaxy plunges through space, its gas and material are literally being stripped away. It leaves a glowing trail of destruction that is completely invisible to normal light. Wild, right? Section 6. Solving Future Space Puzzles. The ongoing investigation into the dark? Even with all these incredible clues from Hubble and our X-ray data, the case file on the Great Attractor actually remains wide open. Because the dust is thickest right behind the center of the Milky Way, a massive chunk of this gravitational anomaly is still completely unknown to astronomers. Like, we found the Norma cluster for sure, but the calculations suggest there has to be even more mass back there to fully explain the exact speed and trajectory of our galaxy's movement. There's still a massive piece of the puzzle hiding in the darkest part of that foggy window. But the investigation continues, with NASA's next-generation Roman space telescope arriving in Florida ahead of its launch. We are very soon going to have even better tools to solve these deep space puzzles. This new observatory is designed specifically to capture massive panoramic views of the universe in infrared light, which, as we know, is exactly the forensic tool we need to finally map out the rest of the Great Attractor. So, my fellow investigators, knowing there is this truly enormous, invisible force pulling on us from behind a wall of cosmic dust, what else do you think is hiding in the dark, just waiting to be discovered? Because let me tell you, as our tools get better, our universe just gets wilder.